Hi all. In this session, we are going to discuss the ultrasonic welding process. As the name indicates, you can say it is something related to ultrasonic frequency. So basically, this process is being carried out by using the ultrasonic vibrations. So that is why the name ultrasonic welding. And this has been mainly used for making the joints between two thin sheets, or this is exclusively used in the case of plastics, especially in toys and all the things. This has been widely used, but this is also used in some critical applications like aeroplane and nuclear areas. Also this can be used. So that is the ultrasonic welding. So now again, this is a solid state welding process. This can be categorized into a mechanical process because there is both friction and pressure is involved. So this is a solid state welding process where the joint is achieved by the combination of friction and pressure. So now in the further slides we will see how this is being carried out. So if we are going to define the ultrasonic welding process, this is a solid state welding process in which the coulsons is produced at the surface by the application of high frequency vibrations, while the workpieces are held together under moderately or low static pressure. So that is a definition. Basically, this process is carried out by using the ultrasonic vibrations. That means the vibrations are applied to a workpiece which is being held in a clamp. So in this schematic diagram you can see the process. The green color is the weldment, or that is the workpiece. Now that is held between two clamping components. That is, the anvil is supporting from the bottom side, and from the top side you can see some arrangements. Basically the components are the transducer, sonotrode and anvil. So now the function of the transducer is to create the ultrasonic vibrations. So basically a transducer will convert the form of energies. If you are giving mechanical energy, it will produce a voltage. Now if you are giving a voltage, it will produce mechanical vibration. So that we are making use here. You are supplying the electrical energy to the transducer that will create the mechanical vibration. So that vibrations are in the order of ultrasonic frequency range. Now that vibration is carried to the workpiece using sonotrode. So sonotrode basically consists of the transducer tip and the component that is vibrating. So simply you can say the vibration from the transducer is connected to the sonotrode. So now the sonotrode will vibrate. So you can see here the sonotrode at the same time it holds the workpiece and also it vibrates. Now the function of the anvil is to support the workpiece. So if we are discussing the mechanism, the clamping force is applied perpendicular to the interface to the workpiece. So workpiece is horizontally placed. So now from both the sides it is been clamped to the perpendicular direction. Now the contacting sonotrode. Sonotrode is the vibrating part that will oscillates parallel to the interface. And the combined effect of static and oscillating force produces deformation and which promotes the welding. So at the interface of the, or at the area where the joint has to be formed, the sonotrode tip will vibrate in the ultrasonic range. So as a result of this vibration, there will be set friction between the workpieces and a moderate amount of heat will be produced. Due to this, deformation will be taking place at the interface. And due to this deformation, the bond is being formed and finally it will lead to the formation of the joint. So that is a mechanism of joint formation. Again, you have to keep the names in your mind: the transducer, the sonotrode, the anvil, then the function of the sonotrode. Now if we are discussing the variants of the process, you can perform different types of welding: spot welding, ring welding, line welding, continuous seam welding, and micro miniature welding, among which the spot welding, line welding, and continuous seam welding are very popular in practical applications. So these are the variations of the process, ultrasonic process, or you can use the ultrasonic welding to perform any of these welding variations. Now this is a peculiar machine used for the spot welding. You can see the transducer and sonotrode and the anvil clearly on this, how the workpiece is been placing and how the sonotrode vibrates. That will be more clear from this picture. This is a peculiar machine. Again, this is another schematic diagram for this spot welding machine. Now, talking about the ring welding, mostly this welding will be carried out in a ring shape. So these are some examples where the ring welding is being implemented. In this, you can see cover to machined container. That is very much practically seeing one. Mostly the beverage cans, that means the Pepsi or Coca-Cola cans, you can see the container will be machined and the cover plate is actually joined to the container, and that is been performed by the ultrasonic welding. Using this welding that can be performed. That is one of the application of ring type ultrasonic welding, cover to machined container. And this is the attachment for continuous ring type ultrasonic welding. There you can see the sonotrode tip will rotate in a surface about to the support of the transducers. You can see it here. This is another mechanism for continuous seam welding. In all these cases, the sonotrode mechanism will change. The shape and the movement of the sonotrode mechanism will change. Other principles will remain same. Now, in this figure, you can see two types of arrangements. One is for roller welding and one is for spot welding, ultrasonic spot welding and ultrasonic roller welding. On the left side, you can see the ultrasonic roller welding, or sometimes it can be referred as the seam welding. That means throughout a linear line or linear direction for some distance, you can perform the welding. That is not possible in the case of spot welding. But in the roller welding, you can note down the shape of the sonotrode. It is not in the shape of, as in the case of spot welding, it is in the roller type. So that the sonotrode at the same time vibrates and it rolls on a linear direction. So that is the thing. Now the variables controlling the process. That we are for all the processes, there will be some process variables that directly depends the welding process. That are the in ultrasonic power, clamping force, welding time, frequency, and linear vibration amplitude. So in the case of ultrasonic welding, these are the 5 important process variables: the power, the clamping force, the welding time, frequency, and vibration amplitude. Now here you can see the power. Electrical power is 60 Hertz is applied to the frequency converter. Now the supplied 60 Hertz will be converted to very much high frequency ranging from 10 to 75 kilohertz. That is 60 Hertz is converted to 10 to 75 kilohertz. That is the range of frequency converting that needed for the successful ultrasonic welding, and that is done by the transducer. So this graph shows the sheet thickness versus machine size, and how the machine size varies depending on to the sheet thickness. Now you can see again, if we are discussing the process variable power generation, you can calculate the energy required using the relation E is equal to K into HT raised to 3 by 2, where E is the electrical energy, H is the case hardness number, and T is the thickness of the sheet. So from this you can say the energy requirement depends upon the hardness of the material and the thickness of the material. So using this you can find out the energy required for the welding. Then the same equation once more it is being described here. Now this diagram shows the relation between minimum electrical energy versus Vickers hardness number. That is, as the hardness of the material changes, how the minimum electrical energy varies. That you can see from this picture. Now, clamping force is another one of the important parameter that decides the success of the ultrasonic welding process. Before the process is being carried out, the workpieces should be clamped properly so that whenever you are applying the vibration, the proper joint will be formed. And this slide you can see the power capacity versus clamping force. Now in this you can see the power level versus static clamping force. The clamping force varies from minimum to maximum and the power level minimum to maximum. You can see here how the deformation ranges. That is at the middle level, at the point F of the static clamping force, and at the medium power level you can see the weak bonds are forming. But the static clamping force is medium and the power level is higher, then the excessive deformation will be developed. So in short we can say the deformation that is leading to the joint formation depends upon the combination of power level and the clamping force. That is, the clamping force and the power level should be in accordance with the compliance. Otherwise, the deformation will not be in the satisfied level and the joint will also be less strong. Now, another some important things related to this ultrasonic welding is the sonotrode tip and the anvil material. You can see the high speed steel tools can be used as the material when you are using the weld materials as soft materials, aluminum, copper, iron, etc. Whether if you are using a hard high strength metal alloys as your weldments, then you can go for hardenable nickel based alloys used welds. Now what is happening at the interface of the material when you are performing the ultrasonic welding? So basically in this localized temperature rises will happen, that is at the point of contact of the sonotrode tip where the vibrations happening, there will be localized temperature rises happening. Not a much HIZ or other temperature disturbed regions are forming in this, only localized heating will be formed. And this temperature is influenced by the power, clamping force and the thermal properties of the materials. Now, as a result of this localized temperature rises, localized plastic deformation happens. Again, all this happens in the localized regions where it directly comes contact with the vibrations. So now here you can see the one spot joint is being formed. Then you can see in the lower figures, the first figure shows before the material before the welding. There you can see the green lines are the oxide layers and the black line indicates the surfaces where the surfaces are actually in contact. At some point only it is in contact. Now the ultrasonic welding is carried out and you can see after the welding the joint is being successfully formed, the oxide layers are broken down and the interfacial surfaces are actually joined together and a metallurgical bond is formed. Now these are some macro images of the welding that showing the different conditions. You can see some local plastic flow, some trapped oxides. All these are some expanded view of the weldment. Now talking about the advantages of ultrasonic welding, no heat is applied and no melting occurs. Of course, whenever the heat is applied is low and melting is low, the weld distortions are also will be less. Then it permits the welding of thin to thick sections. Comparatively, it is used for thin, but you can go for some thick section also. Even though some surface coatings are there in the material, then also you can perform the welding operation. That is one of the main advantage. The surface coating is not a problem in the case of ultrasonic welding. And the welding time, you can complete the welding time in seconds actually in the case of ultrasonic welding process. So now some limitations. Now the thickness of the component should not exceed beyond a certain level. Then the process is limited to lap joints. That is one of the important limitation. It is limited to lap joints. If you are going in the case of butt welds, the supporting will be a problem. As we discussed in the previous slides, proper supporting and clamping force is very much important in the case of ultrasonic welding. That will not be possible in the case of butt welds. That is why ultrasonic welding is difficult for the butt configuration. Now other process variations, even though we are discussing it as process variations, these are actually widely using welding based on the ultrasonic principle. Now non-metallic ultrasonic welding and plastic welding. Of course the plastic welding is very much practically using one. Almost all the toy manufacturing area, the welding is being carried out. That is, the plastics are being joined using the ultrasonic welding process. Now the plastic welding, the advantages are very fast, can spot or seam. A spot welding can be made, or a seam welding can also be made, and the process is very fast also. And as the plastics cannot be exposed to much heat, this process is very much suitable for the plastic welding. Then the limitations regarding the plastic welding are the complex equipment, small parts can be only be used. All the plastics cannot be welded using this. Now the applications of ultrasonic welding, assembling of electronic components such as diodes and semiconductors with the substrates. That is again one of the popular application, assembling the semiconductor parts to the boards of the electronic devices. Then electrical connections to the current carrying devices. Then encapsulation and packaging, that is the example we have discussed earlier, the beverage bottle caps. Then plastic parts. These are the popular applications of ultrasonic welding. Now you can see here the images of the applications we have discussed in the previous slide. So in the left image you can see the starter motor armature with wires joined in commutator slots. That is, the wires are being, armature is being joined to the slots. Then the right side figure is the helicopter access door. All the spots you can see in that door is being welded ultrasonically using ultrasonic spot welding. Then this is another example for the electrical accessory related application, field coil assembly by ultrasonic welding. Then this is the popular example of the container cover. You can see the serial number 1 is the machined container that is not covered with the lid. Then now in the third image you can see the plate is covered over the container. Now the ultrasonic welding is carried out and the cylinder top can be fixed like this. Then this is the clad welding, that is to cover the surface of something using ultrasonic welding. Then this is ultrasonic welding of eraser holder on the plastic pencil. This is very much we are seeing in our day-to-day applications. At the top of your pencil there will be an eraser, and that is held by a steel or some metal parts. And that is actually welded using the ultrasonic welding process. That is the eraser hold on the plastic pencil. You can see in the right side figure at point 15, 14, 15, 13, all these are area where it has been ultrasonically spotted to the surface. And then some gas generator for auto airbag, where the airbag is being used. There also the ultrasonic welding is used and the gas generator. You can see where the ultrasonic weld is formed. So this is regarding the ultrasonic welding process. So you have to keep in mind what is ultrasonic welding, how this is being carried out, what are the components of the ultrasonic welding equipment, then what is happening at the interfacial layer, that is how the joint is being formed, then the process variables, then the process parameters, advantages and applications. Okay.